Right, so question number, I'll start with 20. What do you see? Okay, you see a small triangle and a big triangle. Okay, and the question is that they give us these segments, obviously, that are already labeled, and they want us to explain why they are parallel. Okay, we can put the triangles on there, Jai, but that's not going to prove the parallel. So our job is to prove that they are parallel. We went over this a lot in the other days. Obviously, if you're seeing two triangles, you're setting up two proportions. And what was the proportions that I keep telling you guys over and over again? Big triangle over small triangle equals big triangle over small triangle. Okay. Now the small one's easy. It's the green one. What are the two numbers I'm going to use? 3.75, that's the small on the left, over the small over here on the right. Now that's the misconception, Harsha. Harsha says 5. Okay, now the hard part is that the 5 only represents what? Is the 5 the big triangle or the small triangle or neither? It's neither. It's neither. I need the whole thing for the big triangle. I need from here to here, so I would have to add both of these pieces. This would become 8.75. Now, I would have to do the same thing. They tried to trick you. They gave you 6, but I need the whole. What's the whole here? This is 10.5. So this is 10.5. Okay. Now notice there's no x missing. There's nothing missing. They gave me everything. They're just asking me to prove that they're parallel. So what would you do with these numbers? Cross multiply them. What is 8.75 times 4.75? Don't round it. Okay? You don't want to round it. You want to leave it as it is. Why? Because we're testing to see if they're equal. Now I do the other part. 3.75 times 10.5. What you'll notice is that you get the same thing. And should we? We should, because they're asking us to prove they're parallel. Now, this proves it because this is considered, Damien, as the side splitter theorem. If the sides are proportional, then these pieces must be parallel. So, AB is parallel to CD because the sides are proportional. And we could only use big over small equals big over small if they were parallel, but here we're trying to prove they're parallel. Hence the reason why every single question that you've been getting, they tell you they're parallel first. Okay. Now the concept that I did here that you needed the big is going to happen in number 17. Don't use the pieces. You need to use big triangle over small triangle. Okay, so I want to cover one of the more challenging ones, and which is Tiani's call on number 18. 18 is obviously another one of the more challenging ones. 17 is semi-challenging, but if you apply the concept here that you need to make sure that you're getting the big and not the piece, then you'll be just fine. Okay, in 18, In the diagram below, triangle ADE, they give you point B and C such that these things are parallel. Now they give me numbers. AC is x minus 3. BE is 20. AB is 16. And AD is 2x plus 2. Okay, so don't get tricked. We're still doing big over small equals big over small. Okay, whenever we see it split like this, it's a proportion. Big triangle over small triangle equals big triangle over small triangle. Okay. The easiest one is always the small triangle. You don't have to worry about adding sides or anything like that. Usually they're given. What are my two small numbers? 16 on the left, and x minus 3 is on the right. Okay. Now remember, I need the big piece. The common misconception would be to use 20. 20 is not the big piece. 20 is only from B to E. I need the whole, which, yes, is 36. The whole here is 36, and that represents the big triangle. This only represents a piece of the big triangle. Okay, what's the big on the other triangle? They gave it to you, 2x plus 2. They didn't try to trick you. It was very straightforward. They gave you the whole thing from A to D was 2x plus 2. Okay. So now I'm going to go ahead and cross multiply. This one's trickier because it's an open-ended question. It's not multiple choice. Those extended response questions are meant to throw you. When you cross multiply here, 36, does it get multiplied by just one or both of these? Both. What's 36 times x? Minus, because there's a minus sign. What's 36 times 3? 108. Equals, and then you do the same thing on the other side. What's 16 times 2x? Plus, because there's a plus sign, and what's 6 times 2? It's 32 again. Now, this isn't as simple as, oh, now we can just divide. This actually gives you a multi-step equation that we would need to solve. Okay, bring these over to here, the x is over to the left, and bring the number over to the right. I'm going to shortcut it so that you guys know what you guys are supposed to get. Because I subtracted the 32 on this side from the 36 over here and got my 4x. And then I added the 108 over to the right and got 140. No, if kids are doing it right, then they should get this as their answer. What does x equal? 6. I like 35 much better. But is that what they asked you for? We want to find the length of AC, which is right here. So I just do 35, take away 3. So AC equals 35 minus 3, which is 32. And this is my final answer. Now notice, I don't put a box around anything, and you shouldn't do that on the Regents exam either. We're trained to look for them. Now, if you did work, right, and you never know which work is correct, but you got two different answers, let's say you crossed off the right answer and left the wrong answer. You get 0 points. Yes. If you crossed off the right work and left the wrong work, you would get 0 points. If you left both of them and did not cross either one of them out, but one of them is the right answer, we at least give you half the points. So never cross anything out unless you absolutely know it was the wrong thing to do. Because if not, then we can still give you half the credit even though you have 2 answers on the paper for extended response only. If you pick 2 choices for multiple choice, it's definitely wrong. They don't even count it. Okay. So from here, guys, I want you guys to try to finish the rest of this sheet. It's the same idea. Big triangle over small triangle equals big triangle over small triangle.